Hello.
Hi. Hi.
Hello, dear world. Welcome to our next meetup. The last one was in June, so now it's August, and I'm really happy that Stefan made it possible to make all the way from Austria to YouTube, so to say.
I was great. It was just going upstairs and then and here I am.
Yeah,
So
yeah, it's
it's
easy in these
fantastic.
times, like beaming to Frontend RheinMain. Yeah, welcome.
Thank you.
And I hope this will be a great evening with this awesome topic. Yeah, so welcome all. Please use the chat as hell, so to say. We will do the raffle most likely in the chat later. Yeah, and enjoy the event. And now we have some small intro, and then we get started. Yeah, hi again. So before we start, I want to have a big thanks to the Smashing Magazine people. They made it possible that we can actually have some nice goodies. Like
Oh,
this is
cool.
the
You, you got
this
that
is
one
the
too? Cool. I
Smashing.
have it as
Yes,
well.
you have it as well. That's nice.
Yeah.
Let's throw it. That's nice. Yeah.
Cool.
We are also happy that we are official partner of the Smashing conference starting in September in Freiburg. We will share some info later. And this is like the book we will raffle
Fantastic.
later. And
Cool.
no, this way. This here, no other way. This here is the author.
Yeah.
Stefan.
I've done that.
Yeah, happy to have you here. That's wonderful. And before we start, how did you come to Rust? I mean, I would assume it's a bit similar to me. I did not do much with Rust yet, but I got curious as a classical web developer. And there might be other people who know Rust a bit longer. Rust is got quite some nice hype recently. And how did you discover Rust? When did it start with that?
I guess I've been doing Rust now for I'd say almost 3 years. I have to look into my presentation because I have an actual year bubble somewhere. I guess it was 2019,
Okay.
and it was kind of by accident. So I heard from it through Ryan Levick, who spoke at our Working Draft podcast. So my friends and I run the German podcast on web development, and we had Ryan here to talk about WebAssembly. And he spoke a lot about WebAssembly, but he drifted off to Rust all the time, and I got really curious about it and researched it. And then I kind of got nerd sniped. It seemed like fun. It seemed like something that was challenging me again to learn. And in the end, not only did I have fun learning it, trying it out, but soon after learning it, I found a lot of use cases for this programming language. For things that I would not have been able to do otherwise. And this empowerment that you get, that you suddenly realize, oh wow, I can do that now. I don't need to rely on others to achieve whatever goal, but it's in my hands, and I have a co-pilot with Rust that helps me. This was fantastic, and this is what really got me into it. And now for the last 2.5 years, I've been doing almost exclusively Rust. So I completely abandoned the front end shit now. So seriously, so I guess I wrote my last line, my last front end line in 2021, and focusing now full on Rust.
Okay.
And
this
enjoying
made
it a
me
lot.
really curious now, because I mean, it's obvious that you also have this quite some JavaScript background. Then there was a time when TypeScript came and everyone was like, oh my God, now that's like the holy grail we finally have now. We can call JavaScript now more like a coding language finally with the help of TypeScript, like a real language. And it's interesting that you say even like beyond all what TypeScript offers, and I mean they are progressing also really fast since they released it. That beyond TypeScript, there's even like kind of better, more modern, cooler, whatever thing called Rust, which is a fit for web development as well, which was not on the
the fun
radar
thing
maybe
is
for many of us, right?
The fun thing is, I would say it's different. So I still do a little bit TypeScript, mostly on the backend now, but still. And actually, so I don't want to spoil too much because it's part of my story then. But I found a way to do everything all together at once, so which is quite nice. Yeah.
Okay. Cool. I think then the stage is yours, and
fantastic.
Enjoy the talk and stay here in the chat in YouTube if you want to win this awesome book. I cannot mention this enough. This book is awesome. The layout is nice. The content is wonderful.
It's so beautiful. So the smashing folks outdid themselves. I just provided a couple of markdown files, and they made something like that out of it. That's fantastic.
Wahnsinn. I just said the English word Wahnsinn. It's wonderful.
Great.
Okay, then let's go. Enjoy the talk and talk to you later. Here we go.
Alrighty, cool. My slides are up. Then let's go into my notes. Yeah, so actually I want to make this a rather personal story. So I already spoiled a couple of things. But I think if you know how my approach was to Rust and what I get out of it, I think you might understand why I'm so excited about this new wonderful tool. And I recently turned 40, and which means that I've seen already a lot of things. So I started out in the 90s with programming. I did a lot of PHP, Perl, and Visual Basic. I always say, hey, that's okay. I was a teenager. I'm supposed to experiment with things and get away with it. And actually, it's not here to ridicule those programming languages, because they really got me hooked, and I was able to do a lot of great things. I was able to create user interfaces that felt like bought software from Microsoft or something like that. And with PHP, I was able to create my first web server. So wow, that was pretty cool. As a teenager, that got me so hooked that I started learning computer science, or enrolling in computer science at university in Linz, where I'm from. So I'm from Upper Austria in Linz. And there around 2000, pretty much around 2000, everything was Java in Linz. So Java everywhere. They just switched their entire curriculum from a myriad of programming languages to focus entirely on Java, to learn everything that is related to Java. So we were kind of brainwashed to have this programming language as the only one programming language that matters. Not entirely. So I also did a little bit of C and C++ in computer graphics, which was very interesting to me. So totally different in how you handle it, even if the syntax is similar, but it was very different in how it was handled. So I basically grew up on, or got professional on those two programming languages, which also led me to my first job. So I got Java on the job. And then I kind of switched back and forth between having Java on the job and then C++ and C# again, writing computer graphic algorithms in C++, creating C# user interfaces, because creating those user interfaces in C# was basically drag and drop of a couple of controls, writing a couple of event handlers, and you're done. And then you can call those fantastic C++ algorithms. Still, in my opinion, the best foreign function interface that there ever was. So if you had Visual Studio and integrated those two programming languages, that was really, really nice. Yeah, and back and forth, Java, C#, Java, C#. And around 2011, 2010, 2011, I was at the point in my life where I thought, screw the entire industry, I'm going to become a teacher. and totally serious. So I decided to study linguistics in Salzburg. I even enrolled at the university there, tried to become a teacher in German linguistics and computer science, because, hey, I already had that. Why not benefit from it? But since I wasn't a freshman anymore and already had a couple of years on the job, was basically you call it Selbsterhalter in German. I had to find a job to finance my studies. And I said, back in the day, before I got into computer science at all, I did websites, and that was nice. So maybe some company employs me part-time to do websites. And this is when I came in touch with JavaScript for the first time, when I joined a digital agency in Linz. And how should I say it? It was like getting the Catholic youth to Woodstock. Suddenly, you were allowed to do everything. And not only were you allowed to do everything, you were supposed to do everything. And this was so revigorating for me. So I found new love for software development. I found new love for doing projects, for coding all day. That I dropped the idea of becoming a teacher and then all in web development. And for about the last decade or so, I created websites, I created design systems, I was proficient in CSS, HTML, and JavaScript. I worked with front-end frameworks, I worked without front-end frameworks, I created front-end frameworks, I let front-end frameworks die, all of that. So it was really, really fun. I also adopted TypeScript in the last couple of years and enjoyed that a lot because it was a fantastic way of getting tooling on top of these wonderful programming languages that you had, which even led me to my book. So I was all in web development, around about 10 years. And then, all of a sudden, 3 years ago, where's the animation? There it is, sorry. 3 years ago came Rust. And Rust was different. And Rust did surprise me. Let's put it like that. So what is Rust? You might have seen this logo already. This is the Rust logo. And what you maybe also have seen is the Stack Overflow survey that is released once a year. And it just got, I guess, a couple of months ago. And Rust has taken, again, the top spot as the most beloved programming languages for the 7th year in a row. And there's a very good chance that it will also be the most beloved programming language for an 8th year next year. That's how popular Rust is. It's not one of the most used programming languages, but once people are using it, they are hooked. They love it. And there's a lot of stuff that is very unique about Rust. Coming from my background, basically doing everything, doing scripting language, doing interpreted languages, doing C, C++, Java, C#, JavaScript, whatever. Rust had a couple of features that intrigued me. So first of all, Rust is a compiled language to machine code, which means that you get native speed. They use the LLVM, the low-level virtual machine, to compile to native code. This is a compiler frontend that is used also by Go, and there's a C++ compiler backend for that as well, which means that you compile to this instruction set of the LLVM, and LLVM creates a binary for your system architecture. So you have an executable for a Mac, you have an executable for Windows and for Linux. It has no runtime and an optional standard library. So yeah, there's a standard library like you have it in Go or Java or whatnot, but it's totally optional, which means that you can create very small binaries for architectures that are not that common, like embedded devices. And one thing that was the most interesting to me is that it had guaranteed memory safety without garbage collection. So if you're writing JavaScript or Java or C#, you usually have a garbage collector, which means that you're allocating memory, you're filling it with data, and instead of manually clearing memory again, the garbage collector is taking care of your garbage. So it checks if there's still pointers to your memory, and if there aren't, it clears up the memory for you. This is great because managed memory creates a lot safer applications, not 100% safe, but a lot safer, but it costs time. So this is the trade-off. Alternatively, you have C and C++ where you manage memory manually, and you can do a lot of nasty things there if you don't manage memory correctly. I've written a lot of C and C++ applications, and back in the day, people were supposed to turn off the computer at the end of the day. This was the only reason why I didn't have memory troubles with my applications, because somebody was turning off the computer. The guy who clears the shift at BMW was my garbage collector, and I'm very thankful for that. So, but hey, you get guaranteed memory safety without a garbage collector. So no manual memory management and no managed memory with a garbage collector. Something in between, something entirely new. So this was interesting. And then the Rust team advertised this programming language with 3 fantastic claims that ring to this day. Debug at compile time, very interesting. If you come from TypeScript, you know what compile time error discovery can do for you. Hack without fear, which is the Copilot thing that I'm talking about, and zero-cost abstractions. Write native code that is the fastest code possible, but write like you are in a very high-level managed language. And it's not only me that found those things interesting. So right now, Rust is adopted for Linux, for the Linux kernel. And those are a couple of claims the Rust for Linux team is making. There is no undefined behavior. There's memory safety and the absence of data races. We're going to see an example on that later on. There's a very strict type system for further reduction of logic errors. This sounds a lot like TypeScript to me, and it's very, very similar to TypeScript. You have safe code, memory safe code, but if you need to have memory unsafe code where you are managing memory on your own, you have a clear distinction between that. You have a keyword that tells you, wait, here be dragons. Be aware, everything that happens here can go wrong because it's your responsibility to do that. And then you have a featureful language, you have a wonderful standard library, and you have fantastic tooling. So it's so great that you don't have to global together all your tools from NPM or somewhat, but you're installing Rust once and you have everything there that you need to get started. This is beautiful. If I want to describe Rust in 3 topics, it would be memory safety without garbage collection, abstraction without overhead, and fearless concurrency. And I want to show you examples for all 3 of them. Let me start with memory safety without garbage collection. So in unmanaged programming languages like C and C++, you get errors like use after free, which means that you have memory allocated, then you free it again, but hey, you still have a pointer that points to somewhere, to void, to the nothingness, and you still want to use it. Bam, your application crashes. The other problem that you have is double free. You allocated memory, then you freed it, and hey, at another place, you are going to free it again. Bam, your application crashes. You have buffer overreads and overwrites. Maybe you didn't allocate too much memory, which means you can overread it or overwrite it. Or you have null pointers. And null pointers is something that I guess you see in every programming language. Undefined is not a function anyone. Yeah, that's what I'm talking about here. This is something that still haunts us to the day. Or for all the Java folks in this round, null pointer exception. You have definitely seen that. So those errors exist, and they exist because it's your responsibility to manage memory. And I mean, the principles of managing memory on your own are easy. You're allocating it, you're freeing it. But the problem is that you don't know when to do that. Or even if you do know when to free memory, you need to compose your software with software from others. Are they thinking in the same way that you do? Are they taking care of memory management the same way that you do? And suddenly, you need to have a couple of memory models in your head and need to manage them all on your own. And this is where it happens. And according to Google, this is from the Google security blog, in Chromium, around 70% of their memory security bugs, of their security bugs, severe security bugs, are memory safety problems. The stuff that I just talked about. 70% in Google Chromium security bugs. Same number, different vendor. Microsoft said the same thing. Microsoft says from all the vulnerabilities, Microsoft signs a CVE. 70% continue to be memory safety issues. That's a ton. And those issues, Rust wants to get rid of. And Rust gets rid of those issues with what I like to call the Highlander principle. I don't know if you grew up in the 90s, but this was Christopher Lambert in the first Highlander movie. And for everyone who remembers that, the claim was there can be only one. And that's the principle of Rust's memory management. It's called ownership, which means that each value that you create, each value that you assign, has one owner. And with one owner, we mean exactly one owner for each piece of data. When the owner goes out of scope, which means a curly brace closes, the data gets cleaned up. Owners can transfer ownership to other owners, or they can borrow, fuse into your data. But there's only one. There's only one owner. There can't be another one. So how does it look like? This is some code that you usually would see in any programming language. So I have a vector. Those are the first, how many? 6 Fibonacci numbers, and I store them in a vector. So a vector is a collection on the heap. In that case, it's a collection of numbers, and it can grow, and you can modify entries, etc. Kind of like in a range JavaScript. I store this vector under the binding numbers. And then I create another binding, other numbers, and I let point it to numbers. And then I want to print both. I want to print other numbers and numbers. And in Rust, this is an error. So I get an error at this position, and the Rust compiler says, hey, borrow of moved value numbers. So I want to use something that has already been moved to another binding. This is what there can be only one means. I have two bindings pointing to the same memory address, and Rust doesn't allow this. The moment I assign numbers to another binding, there is another owner, and numbers points to nothing else, and the compiler tells me that it points to nothing else. And this can be very confusing at the beginning. So this is something that you don't have in any other programming language. And if you see that, it's like, oh, what's happening here? This causes confusion, this causes troubles, but there's a very clear rule set underneath it. And let me go into detail. I'm going to show you a couple of things that I borrowed from Nico Matsakis, who has done a fantastic presentation on this. It's a nice visualization to see how ownership works. I have a function. I'm creating another vector here. Now I'm writing a book, which means I have a book vector, and I push a couple of pages into my book. This is here and here. And then I call the publish book function twice. In memory, it looks kind of like that. So I have this pointer structure on the stack. It has a buffer pointer that points to some address, to some memory. There's a capacity. How many entries does it have? Or how many entries can I store before I need to reallocate memory? And there's a length, which means how many entries are already in there. And this buffer pointer points to some data on the heap. I'm going to fill it with a couple of pages. Then I am at the publish function, or calling the publish function. The publish function, based on its signature, takes ownership of the vector. This is a consuming binding, which means at this point where I call publish book, the main function gives ownership to the publish function, and the publish function takes ownership of book. I move the ownership to the other function, which means the data structure is now on the right-hand side. It's now with publish, and it disappears on the left-hand side. There can be only one, and that's exactly what it is. So right now, there's another owner. Book has another owner. It's publish. Publish is being called. I'm at the end of publish, which means end of curly brace. Data gets cleaned up, and there you go. All the data goes up in flames. When I return to the other publish call, where's my data? Book doesn't point to anything because I transferred ownership already, which means this causes a fantastic error. This is the base principle of ownership. There are no implicit copy constructors, but you can call clone, which means you can duplicate data if you need it, which is, of course, expensive. You know, if you have lots of data and you clone it, which means you create a duplicate of those data in memory, that costs. But that's not usually how you make sure that other functions can work with the same data. There are better ways to do that. One thing that is interesting in this whole principle is that everything that we've just seen here is enforced at compile time, which means the compiler throws an error if you have an ownership problem in your code. If it compiles, you're good. All memory movements are done. They are set. You know, the compiler knows what's happening. The compiler knows how to allocate and deallocate memory. But again, it's boring if you would have to clone everything or move ownership all the time, which means we have other ways to do it, which brings me to borrowing. Very similar setup than before, but here I have another function signature. Instead of taking the ownership, I have a reference to this vector. So I'm having a shared reference denoted with this ampersand. It's not part of the type. It's very clear when I read this function that this wants to borrow data. And I also have to create those references with the ampersand. So it's also clear here in how I use it that this is a reference and not something else. Same setup as before. So I have this data structure on the left-hand side. It points to some data I call publish book, but with a shared reference, which means now that publish has a reference on this data structure. It's borrowed, and it's a readable borrow. So it can read the same data that is stored on the book. I'm calling publish. It has a shared reference. It goes out of scope. The reference disappears, but the original data is still there. And then I can call publish again with the same data by having a shared reference. So this is how you create readable borrows. There's also the possibility of writable borrows. Same setup here, but here I'm going to add another keyword, which is called mute for mutable, which means that in the function signature, it becomes totally clear that this wants to change something from the original data, which means that the compiler it creates this mutable reference, a book, and it locks writing access to the original memory for anything else, which means you can't have multiple mutable references. You can't have any other data writing something to book if this mutable reference still exists. It's a nuanced detail, but it's very, very important, which means that you don't have any data races. You're not changing the data. You're not reallocating your vector just because something is written in your memory while somebody else has mutable access to it. And then the same spiel happens again. It's now an edit function. I go over to the edit function. I have a mutable vector here. I push another page. I'm at the end of the scope. The mutable reference disappears. I'm going back to the edit function, and I can do the entire spiel again. So there are three things in the whole ownership and borrowing rules. Either the type is owned, then you can mutate it, or you have a shared reference, then you can have a couple of aliases that point to it and read from it, or you have mutable references, where you can still mutate it, but you're not the owner, which means you can easily pass it to some other function. And this sounds like a lot of extra work for simple things, but what you get is optimized memory allocation and memory freeing. No possibility of anything like those typical errors like use after free, double free, no performance overhead through a garbage collector. It's fast, it's secure, and you don't have any troubles with your memory, because every memory movement is known at compile time, which means, of course, compile times are pretty long actually. So this is something where you miss performance in Rust. Compile times take some time, but hey, they are actually checking a lot of things, so that's okay. And for me, who has done his fair share of manual memory management, it's just so great to have a fixed rule set of how to manage memory and a co-pilot in form of a compiler that tells you if you do something wrong. And yeah, at first, this is excruciating. So it's you are getting so many errors because you're not used to it. But once you get it, and once you know how to work with it, you're writing the best code in your life and the fastest code in your life. And this is so enabling. that I just can't share my excitement for that because it's so much. So this is the fantastic thing about Rust. And very similar again to TypeScript. With TypeScript, I have somebody who watches my code and makes sure that I don't do any errors. And here you get the same feeling, but for memory management. To somebody who I was relying on the guys from BMW to turn off the computer at the end of the day. This is memory management without a garbage collector. Another thing that was really, really nice for me is abstraction without overhead. So Rust has a feature in the language which opens up fantastic doors to the type system. And in other programming languages, you would see it like an interface. In Rust, it's called traits. And traits define shared behavior between types, which means you can define some functions, some methods that a trait needs to implement. And then, I need to accept something that implements this trait and I can work with it. So it's very similar to interfaces in other programming languages, but it's so nuanced that it enables much, much more. And also, it doesn't mean that Rust has traditional object orientation like in Java or C#. It has not. So you are not able to transport inheritance or something like that into Rust. That's not really possible. You are able to implement other object-oriented features in Rust, yes. More traditional, more like in NMK's Smalltalk kind of object orientation, but not the typical stuff that you get from Java or C#. There are differences. And so are traits, because in traits you're not only able to implement your trait for your types or foreign traits for your types, you're also able to implement your traits for other types. You either need to own the trait or the type. So how does it look like? I'm creating a Fibonacci generator. This is my Fibonacci struct. It has a current value and the next value, like 0 and 1, where you start. And then, you just move it along. You just add them, and the result is the next one. And what was next becomes current. And then again and again and again and again until you reach the end of what's possible to display in your type. And I implement this Fibonacci generator by using an iterator. So I take this iterator trait and I implement the iterator for my Fibonacci generator. And the only thing that you need to implement is the next function. And here is exactly what I'm doing. So I'm calling new next. So I'm calling an add. I'm adding current and next and store it under new next and then moving it further. So current becomes next becomes new next, and I return the current value. And in the end, when I don't have any room left anymore in U128, I stop. So this is how I generate it. And with every next call, I get the next number. But I'm implementing iterator, which means my Fibonacci struct becomes compatible with everything that understands iterators, which means I just implement one function, but I get a ton of other functions that I can work with. What I also implement is the default constructor. So I'm implementing default for Fibonacci, which means I can call default, and I know the starting values for that. So this is another idiom in Rust. And this is how it works. This is how it works. So I'm creating a Fibonacci counter here, and then I'm calling enumerate, where I get the index and the value, and I just print out every value that's possible. That's it. And if I don't know how to generate it, I can just call Fibonacci default and generate every number that there is. So with the iterator trait, my Fibonacci counter becomes compatible with for loops. And not only that, it also becomes compatible with everything that iterator does, like create a new Fibonacci counter, take 10 and collect them in a vector. Great. And then I need to check, well, the vector that I created, are those the first 10 Fibonacci numbers? Well, they are. And the Rust compiler is even clever enough to generate those 10 numbers upfront during compile time. So I don't have to compile them. So I don't have to generate them on runtime. That's how good it is. So if it can optimize things like that, it does. That's the power of LLVM. So hey, I'm implementing other traits for my own types. But I can also define traits and implement it for other types. So what I do here, I create the print type because I'm constantly console logging my stuff. This is something that I've taken over from JavaScript. The only debugger that really counts is logging stuff out to see what's happening, and I do that a lot. But the print line macro, which is that one, it's kind of tough to write for me because I suck at writing curly braces. So I created this trait, and I implement print for every type that implements another trait, that implements the debug trait. Debug is exactly, console logging stuff out, getting just information about how the shape is, what values it has. This is the debug trait. But hey, for everything that implements the debug trait, I'm now able to call .print, like for the string or for this vector or for anything else that implements the debug trait. This is how powerful that is. I define a trait, and for every type that exists and will exist, I get this functionality. There's one package on Rust's Cargo, which is called itertools, that implements additional functionality for iterators, which means I get 106 more methods for every iterator that there is and that there will be if I'm going to use this package. Because they say, well, we have an iterator, we know what to do with it. We just implement those utility functions for you. Have fun with it. Even my Fibonacci iterator that I just wrote. There you go. I have 106 methods that I can use on top of the 50 methods that already exist. And this is incredibly powerful. So having this level of developer ergonomics lets you write really elegant code, really performant code with just a couple of packages that you load, because they can add something to the type system for you. Another thing that goes kind of into a similar direction are result and option. So I don't know if you heard about Tony Hoare's $1 billion mistake, but Tony Hoare was implementing algol 60 back in the 60s. And he thought, oh, well, null would be a nice idea. If something is not there, then it should be null. What could go wrong? And he called it now his $1 billion mistake because he thought that it has cost the industry about $1 billion because of all the null pointers that there are. And Rust gets rid of that. So there is no null and no equivalent in Rust. There are no uninitialized states, and Rust forces you to deal with potential errors or values that don't exist. So you need to do something with it. It's funny because in JavaScript, you have two ways of nullishness, like undefined and null. And in Rust, you have none. You don't have something that is similar or nearly similar to null or undefined. You can implement it on your own. People did that, but hey, why would you? It's not part of the language. And it solves that through so-called enums. So an enum is like a union type in TypeScript. You have option, which means it needs to be either none or some value. And for the error, it needs to be either an error or a value. How am I using that? I have this function read username from file here. It takes a path. I can open this path. And here at those two spots, I need to say, well, this opening of that file, did it work? And if it worked, I'm getting the file. If it didn't work, I'm throwing an error. That's those parts here. Then I'm creating a string. It's a string buffer where I load my contents in. I say f read to string, pass the string buffer to load it. Did it work? Great. Then I have my result. Did it error? Then I'm returning an error here. So this is how it works. Rust needs me to check if everything was okay. So I can't leave out the error case. I need to deal with every part of this enum. And even if it's just ignoring it, but I need to deal with it. I need to write in my code, has something happened or did something happen? And again, this rules out a ton of possible errors that exist. There's a shortcut, so I can call unwrap, which means, hey, if it's okay, return the value. Otherwise, panic. Otherwise, break your software, stop everything, exit, throw an error message. That's what you can do. But the difference is that you need to do that explicitly. You need to explicitly say, well, there can be an error. I'm good with ignoring it. I'm good with unwrapping it. And if it panics, it's my responsibility. Which is great, because afterwards, you can look for that. You can see, well, has there been an error? Like here, so we had 129 of them. That was a problem, but hey, knowing in a 10,000 line of code application, that we have 129 possibilities where our program can crash, reduced searching for it tremendously. Now we are down to 5, by the way. But yeah. And to have better ergonomics, what you can do, which is also very nice, you can propagate errors. So here, with the question mark operator, I can write if there would be only good cases, like everything works, everything is okay. But if it's an error, just bubble the error up, and then I need to take care of it in the outer function. But so still, I can write like nothing happens. At one point, I need to do something. Rust still forces me to do something. And it's still explicit. So I still see from the code where are potential problems, where the question mark operator is, and I need to have this one part where I need to actually deal with it. That's something that doesn't go away. That's the type system. So I have a couple of things for the last 10 minutes, so where I want to show you a potpourri of what's also possible. One thing that is really, really nice is fearless concurrency, multi-threading. So the ownership and zero cost abstractions work really, really great if you need to have multi-threaded software. For people who do Node.js, that's like opening two Node.js processes or having web workers or something, like a process on the side. The problem that you want to have, or the problem that you want to rule out, are data races. What if you have two or more pointers to the same data at the same time that are used in different processes or in different threads? They are used to write data. At least one is used to write data, and you don't have a mechanism to synchronize access to the data. And it turns out that Rust's ownership system can really, really help. So first of all, I'm having here a vector, a couple of numbers. I'm spawning a new thread, and I want to print that vector in that thread. This alone causes an error because Rust tells me, there you go. There you go. Stupid animation, I'm sorry. That this closure here, so this function that's called here, might outlive the main function, but vector is owned by the main function and just borrowed here. So the thread might stop after the main function stops, which means the access to the vector might be gone, because at the end of the function, I'm cleaning up my data. With the move keyword, I can give ownership to the closure. I can give ownership to the thread, and now vector is owned by this thread, and it works again. That's great for single data, just move everything there. What's happening if you have multiple access to the same data? So you have a counter, it's a number in a mutex. Mutex, mutually exclusive. I can just one thread can write to it, one thread can do something with it. I'm creating 10 threads, and I want to lock the counter, add something to it, and then let all my threads run. So I want in each thread I want to count up a number at this one particular binding. I get an error. Why? Because I make use of the moved value counter, which means we know that already. Add the move keyword. That's here. But the problem is it's being moved once when I create the first thread, and then it should be moved with every other thread because I have a loop. It should be moved 10 times. That doesn't work. So I need to create something where multiple threads can share the same data. And I do this with an atomic reference counter, or ARC, which means I wrap my number in an atomic reference counter. And with every loop iteration, I clone this counter, which means I count one up. I move the reference counter. I can lock it. I can add something to it through mutually exclusive access. And at the end of this function, I just drop the atomic reference counter, which means I count one down again. This is basically manual garbage collection. With every thread that you create, you count one up. With every thread that you destroy, you count one down. And if all the counts go down to 0, you can clear up the original data. That's the principle here. And with that, it becomes very, very clear, again, from the code, which data is shared across threads, what's the rules, how is it shared, what do you want to do with it. It's in the type, it's explicit, and you have principles there that keep you from doing wrong. And those are primitives that you can, you have those atomic reference counters, you have mutexes, and you have zero cost abstractions through trades, which means you can do something like that. This is, you get an input of a number array, and you want to create the sum of squares, which means that you have an iterator, you map through each value, you square it, and then you create the sum out of it. This is a functional interface. And with a little library called Rayon, you can multi-thread that. The only thing that you need to change is changing it from iter to par iter. Because, hey, everything that implements an iterator can now implement a parallel iterator that is shared across threads, and you have the same functionality that iterators have. Because underneath, it's using atomic reference counters, mutexes, threading, all that stuff. On top of it, it just implements something on top for all iterators that exist. And this is the only thing that you need to do to make your application multi-threaded, to have the computation of what you do here multi-threaded. I've not seen any other programming language where it's so easy to do that. And you have more stuff. You have built-in multi-producer single consumer channels. So if you know Go, where you can send data through channels, you have that in Rust as well. You have marker traits that tell you where, well, this is something that you can share across threads. This is something that you never, ever should share across threads. And you have built-in primitives for green thread concurrency, like async await. But you don't have an async await runtime in Rust. You need to install one on your own to make sure that you install the right runtime for the right problem, like Tokyo for networking applications, or something like async stand for embedded systems, for example. So you can pick your tools, but still have the same primitives. And well, there's much more. There's much more to like about Rust. First of all, there's things like it's immutable by default. So you need to have a keyword to make data mutable. Everybody who loves immutable data, for all the reasons where you can love immutable data for, it's a part of the language. Having the mutable keyword makes something mutable. One thing that I like a lot is shadowing. I can redeclare the same binding over and over again, which means if I have a couple of test cases, I just copy everything that I have, put it underneath again, everything is redeclared, fantastic, it just works. I use this a lot. So if you ever opened up DevTools and create the const X and you bite yourself in the arse because you just want to create another const X just 3 minutes afterwards in the same DevTools and it doesn't work, you want to have shadowing. You have a fantastic control flow. What I love is the match statement. We've seen that already with enums. So here I'm matching a number. And I say, hey, for everything from 0 to 10, you do that. For everything, if it's 15, do that. And for all the other cases, do that. And this is resolving letters to Scrabble counts. So I have tons of letters. And for every letter that I know, I can assign a number. And for all the other letters, well, that might be an error. What do I do with the question mark? What do I do with colon, comma, whatever? Just return 0. And it's never Terza. So this is one of the things that I miss in other programming languages now, to have this expressiveness like the match statement. Talking about expressions, one thing that's also cool, if you have a semicolon, you're creating a statement. If you're not having a semicolon, you're having an expression, which means that you can do stuff like, here I don't have semicolons, which means I say if num is 5, then return 5 and store it in message. If num is 4, then return 4 and store it in message. Else return other and store it in message. So everything that doesn't have a semicolon can be an expression and is basically the next part of another statement or of another expression. Everything in Rust can be an expression, which makes up for some fantastic scenarios where I think, oh, well, at this position, I actually need something. Well, then just write it, because it's an expression. You can have a match statement there, you can have a match expression there, you can have an if expression here, you can have a closure there, you can call that closure, you can instantiate a structure and do something with it. If you're dropping the semicolon, you're always getting a value from it. And this is something that I'm so used to it now, that when I'm writing TypeScript, I'm always forgetting the return statement. Because, well, I'm just returning expressions and it bites me. So this is the things that are weird at first, but are so fantastic once you're getting used to it. There's fantastic tooling out there. So Cargo is basically like your NPM. You have dependency management. You have version and toolchain management via RustUp, which is kind of NVM. You have Clippy, that one thing that knocked against your window in Microsoft Word 95. Well, it's now a linter in Rust that tells you if you can write something better. You have automatic formatting with rustfont, which means that, well, it might not be your favorite formatting style, but it's the formatting style that everybody uses. And that's great. So you don't care about formatting styles. rustfont cares for you. And one thing that's also fantastic, if you have a documentation block in front of a function, in front of a file, in front of a struct, you can embed tests there with the implementation that follows, which means the documentation that you publish is always tested against the actual implementation. I've never seen anything like that in any other programming language. If you want to adopt Rust, couple of things. What you will love Cargo and all the dependencies that you get from Crates. You will rough the tooling through Rust Analyzer. It's one of the better editor LSPs that I've seen. You will love things like expressions, match statements, enums. But you will also love the community because it's really helpful. It's really empowering. It's still very small. And they know that Rust is a tough language, and they really, really help you getting started for basically every use case, every scenario that you want to do. You are finding books out there, free books, tutorials, articles, forums, open GitHub repos. There's such a rich ecosystem of documentation and tutorials that you definitely are getting started with it. What will be hard? First, fighting the borrow checker. This is something so new that you will have troubles at first. Even if you know the basics, it will bite you. It will bite you in scenarios that you didn't expect or didn't anticipate, but you are getting used to it. Which means it also has a very steep learning curve. So people say, well, it takes around 2 to 3 months to get really, really productive in Rust. I doubt that, actually. So we've been adopting it in teams, and people were able to contribute production code within weeks, not months, which is great. If you do Ruby, C#, Java, you need to let go of your object-oriented thinking. If you've done JavaScript, you're much, much better suited for that. But there's no way to implement inheritance and everything that comes with it in Rust. And the standard library is rich and good, but there's kind of a non-standard standard library. Things like regular expressions, asynchronous runtimes. They are all crates and not part of the language, and not part of the language standard library. And you need to find them to know what the community thinks is the best way of doing something. But again, since you have all those great documentation, hey, I'm sure you'll find it. A couple of things that you're going to hear if you adopt Rust. This is Tenable. They changed from Node.js to Rust, and suddenly they were able to optimize away 700 CPUs and 300 gigabytes of memory in their distributed architecture. Wow, that's something. Tilde moved from Java to Rust, and they were using 5 gigabytes of RAM, and their comparable Rust server only used 50 megabytes of RAM. That's something. I'm teaching at the Rust Summit once a year, and a Rust attendee said, well, it's true, they have never written more robust code. This is something that you're going to hear. One attendee from a Better Code workshops said Rust enabled them to do things they didn't think they were able to do before. One thing that I don't have a quote in here, sadly, but that also describes it so well. One person said, Rust is the perfect beginner language because they didn't know anything about memory. They didn't know anything about multi-threading. They didn't know anything about systems programming. But with Rust and the compiler and the community, they were able to achieve something on that level without prior knowledge. They were able to learn it through the language and not through a program that crashed at some point in time. And for me, I got my PPAP moment. Pen, pineapple, apple pen. I had two things. I had a problem and I had Rust and I was able to do something with it. I wanted to create my own JavaScript runtime and I had V8 bindings in Rust. And I was just combining those two. And I'm now, for the last 1.5 years, with my folks at Dynatrace, writing our own JavaScript runtime that executes Node code, Deno code, what have you, and even things that speak to our own APIs. We're able to create a serverless environment with it to execute workloads that are so tailored to our use case that you can't just take an off-the-shelf solution for that. And this comes from me, who has spent the last 10 years creating websites. Maybe I was really good at them. I don't know. I did it for a long time. I would have never imagined to go beyond that, to open up the curtain and see what's underneath this JavaScript engine that executes my code, to see how the sausage is made, and not only to be able to see how the sausage is made, but also to create stuff on my own that works in the same ecosystem. This level of empowerment, this is something that you don't get anywhere else. And this is the actual clue of Rust. Suddenly, you think about things that you never thought before. You're able to do things that you never did before. And this rekindled my love again for programming. This rekindled my love for systems programming. And I'm super happy to spend the next decade with it, to be honest. And this is how much I love it. I love it so much, actually, that I created a meetup, Rustlins. We are one of the most watched meetups on YouTube. So we publish monthly on the Rust YouTube channel with up to 30,000 views per video, which is very nice. And we had lots of fantastic speakers from all corners of the globe, from all levels of experience. So we had talks for beginners, talks for experienced users. If you want to learn Rust, there are lots of videos, about 50, that help you getting started. Pick your use case, look at what they did, and get started with it. I teach Rust at RheinMain, and I still need to put up my order.dev brand website, and I write about Rust on Fed blog. If you want to know more about it, you can reach out to me at @parrot. That's my Twitter handle. And I guess now it's time for the book raffle or for questions. So that's the end of my talk.
Thanks so much, Stefan. Awesome. I think we all can feel your big enthusiasm, your authentic enthusiasm. It's really awesome. It was really inspiring.
Cool.
Thanks for this great hour. It got me hooked even more to try out.
Cool, great.
I already fell in love a bit. I must say, with this. I think it's this Rust playground they offer, right, on rustlang.org. I think where you get into the language just by creating small pieces step by step, and this is made so nice, I must say. And now with your talk, I'm yeah. I want to start something with Rust.
Cool.
Yeah,
That's
cool.
good.
Okay. How many minutes do you have, by the way?
I guess we can chat for a couple of minutes more. Sure.
Okay,
So I
that's
see there are a
fine.
couple of
Okay.
questions in the chat, aren't there? So
Let me just select some questions from the chat and show here Christoph.
Hey, Christoph, cool, great.
You
He's a
know
friend
each
of mine.
other?
Fantastic.
Okay,
Yeah.
cool.
So good to see you, buddy.
Then maybe you can answer his question.
Yeah. Okay. So Christoph wants to know some concrete example subjects where Rust is really, really good. So I drifted totally into the cloud and cloud native area. I already spoke about this JavaScript runtime that we are writing. So we are using V8 and hooking into the bindings to create our own language runtime with our own features for a very specific use case. And this very specific use case is a serverless platform that runs in a Kubernetes cluster along with our software. And what we see, if you work at this level where I don't want to say where you need Kubernetes, because in my opinion, I guess you don't need it or you shouldn't use it. But oh wow, I'm tickling a couple of toes here. I'm sorry, but if you're working in cloud applications at that scale, Rust gives you the possibility to work on a network infrastructure level, to write high performance proxies that are tailored to your situation, that would be tough to write otherwise. I've seen people in-house developing databases with it. So this is something that you can do with it. And especially everything that evolves around the Tokyo ecosystem, which is a networking framework and tool set, is really, really great for that. Microservices, everything that runs underneath microservices in serverless applications, super. So if you, for example, have a serverless application that's distributed in lots of smaller functions, and you write them in Node or PHP or whatever, try taking one of those little functions and rewrite it in Rust and see what performance you gain, and see how much fast it is, and see how much memory efficient it is. And I'm throwing the serverless card here for a very particular reason, because you pay in AWS Lambda and Azure Functions, you pay for time and memory. So the longer it takes, the more you pay. The more memory you need, the more you pay. And if you have a programming language that is very fast and optimized for memory, so memory is everything it's optimized for, then you can reduce your costs for the serverless application significantly by just taking your longest running function and rewriting just this one little piece in Rust and see where you go. And then you can start refactoring. So this is a great place to start. I think I wouldn't do the traditional web server with it. You can do that. There are a couple of great frameworks out there already, but I still find it more ergonomic to do it with others, like maybe a Golang server or a Node server or PHP for that matter. So this works also pretty great. But other than that, embedded systems, I would not write without Rust in embedded systems. Command line utilities, there are tools for that where you can basically define your command line utility in a JSON file and everything is generated automatically on its own. Glue code to other native bindings. So if you have any C library that you want to hook into and use it with your own idea rather than the interface it provides you, that's Rust. So those are a couple of things that I just can say off the top of my head. But it's also a little bit tough for me because I'm in my Rust honeymoon, which means I'm in love and I can't think of anybody else. But
everything is pink for you.
Yeah, but especially the networking stuff. That's something where I wouldn't do anything without Rust anymore, to be honest.
Cool. Another question from Sharan.
Yeah.
Compile time debugging.
Mm-hmm. What did I mean with compile time debugging? So what I said during the whole ownership and borrowing stuff is that all those checks, this entire rule set of that does memory management for you. This happens at compile time. This doesn't happen at runtime. Which means if you have any memory problems or memory errors in your application, you figure them out at compile time. And it turns out that once you figured out all the memory movements, your application runs extremely robust. So I have application running now for close to a year without turning it on and off again, off and on again. And I never had any memory troubles there. I had applications where I had some logic troubles because I didn't figure out what's correct. So it doesn't prevent you from making mistakes. But it's going to be really, really hard to run into a situation where you have an unexpected output or an unexpected outcome. Really, really hard. I'm not saying that it's not possible, but if you're going into the situations where the outcome might not be defined or might not be clear, then you're already very, very deep down the rabbit hole. For all other scenarios, you are going to figure out at compile time through the language features, like dealing with your values, dealing with your errors, dealing with your memory movement. You're going to figure out at compile time if something works or not. And this is also something that I haven't seen in any other programming language. If you know it compiles, and you followed good practices, like not unwrapping your stuff, but actually handling your errors, you are writing software that doesn't crash. It sounds so ridiculous. It sounds like a fairy tale, but it's kind of true. So this is what I meant with compile time debugging. Once it compiles, you can be pretty sure that you don't have any big mistake.
Cool. Next question. Can we develop both backend and front end? Yeah.
So Rust is one of the top languages if it comes down to WebAssembly. So you can write traditional frontends because there are libraries for that compile to Rust, compile to WebAssembly, and generate HTML, CSS, JavaScript for you. I wouldn't do that because it's kind of a turducken, a turkey filled with a duck filled with a chicken. You have Rust filled with your own meta language, which then generates JavaScript. I wouldn't do that. But if you want to create, if you want to offload the main computation for that with something that needs performance or something that would be way too much compute power for JavaScript, WebAssembly is the way to go, and you can do a lot of things with WebAssembly. And Rust has, in my opinion, one of the better ecosystems for WebAssembly. What can you do with Rust? WebAssembly on the server, on the client. That's one fantastic area to explore. So so you can develop both front end and back end, kinda. I already spoke about the learning curve. Don't get me wrong, it's a fantastic language, but it's so different from anything else that it will take time. One thing, I don't know if I can write in the chat here. If I can't, let me put up one web page real quick that I want to recommend to everybody. Not only if you want to learn Rust, but also if you want to learn anything else. You should see my browser window now. Yeah, that's Exorcism. And Exorcism is a platform where you learn a programming language through arbitrary programming tasks, like the Thief of Eratosthenes or creating a bowling score. And which means that you can take off your mind from the problem because the problem is very well defined. You have a big test suite that tells you how the expected input and output is, and you can focus on learning the constructs and primitives of the language. And I did 50 Rust exercises in two to three afternoons, let's say like that. And then I was able to start on problems on my own. So this is something that helps flattening the learning curve tremendously. Highly recommend.
Okay, cool. I think we can after the talk collect some great links. I think there are many of them. Like one mentioned this, I think rustling's repo.
Yeah, rustling is also a fantastic repo.
It's also beside the official one, which I found out already. There are so many things, and they really make a great job in getting you hooked about Rust. Yeah, absolutely. Let me see. There's another question: if traits can clash with method names.
Yeah, very good question. So because the first thing that I was thinking of when seeing that I can implement traits for other types is prototype pollution that you do in JavaScript, where you just add another function to the array prototype and suddenly every array gets this function. So this happened back in the day. This caused a lot of problems and a lot of pain back in the day. And they also said, hey, well, isn't that also the problem with Rust? So the thing is, Rust has a very good module system, and only the things that you import in your module are extending your types with it. If you don't import it, you don't have it. If you just import parts of it, you just have those parts. Which also means that if you have two modules that have the same method names or the same method signatures, you are getting a compiler, which means you can't import both. Great. Then you need to figure out maybe splitting it up in two modules and creating your own higher order functions for that. But that actually rarely happens. So since the module system is so great, you are rarely seeing something that clashes with some other thing. But it's possible. So we tried it. We all tried it out. We all wanted to see how this programming, this compiler bug looks like. Is it hard to find where traits are coming from in existing code? Nope. Rust Analyzer is a fantastic tool that gives you all the information. You can navigate through it. You can go back to the implementation. For every type that you use, if you hover over it, how many implementations there are, which means how many traits you implement. This is all there. You can also implement the trait a couple of times for various configurations of the type. And this needs good information and good documentation. And Rust Analyzer is chef's kiss. It's so good in what it tells you that you are never lost.
Cool. A lot of praise. I cannot put every praise now here in the
you don't need to. I'm reading them. That's great.
You're reading it. That's awesome. Question from my side. How long do we need to wait until your next book, Rust in 50 Lessons, will be released?
I guess you need to wait a little bit longer because I'm writing now my
You're on it?
My second TypeScript book, actually. So right at the very moment, I hope to finish it by the end of the year. But I must lie if I said I didn't reserve rust-book.com already. So I have a couple of ideas. I just need to find my way around it and need to find a way how to contribute something useful and something unique. I don't want to be just the next book. I just want to be a book that kind of like TypeScript in 50 Lessons. There's so many great TypeScript books out there, and they all have their validity and all fantastic. So I own all of them, by the way. And we tried to do something very specific with TypeScript in 50 Lessons. And I guess I need to do the same thing with Rust. And I need to find the idea for that.
Yeah, but I think like the combination with like this nice layout from the Smashing Magazine folks and your enthusiasm, also your writing and speaking experience, this can be condensed in a wonderful book, which like then would add to all those already existing nice Rust documentation assets, so to say. This would be cool. And I personally like to have a real book in my hand in those times, so it's really
Same
a
here.
thing. Yeah,
you should see the back of my screen. It's filled with books.
There's another. I can relate to this. I can feel energy and love for Rust. There's another question
Mhm.
before we go to the raffle. Is there a process or way to get a good handle
So
on
we
lifetime?
didn't speak about lifetimes. So a lifetime is a moniker for the start where a value begins its lifetime and its end. The area in your code where this value is valid and has memory attached to it. And a lot of it is implicit, which means that a lot of it you don't see. But there are certain times where you need to explicitly define lifetimes. And this is where the syntax gets a little wonky and where it's a little bit tough to read and to define it. So this can be this can be a big turnoff when you start learning Rust. If there's a good way to get a good handle on it. So one thing that I basically do every time I run into a lifetime problem is to just right click and follow the compiler until the compiler error gets away. One thing that I can recommend, I have it right here. So this book here, Rust for Rustaceans, is an advanced reading on Rust, and there's one chapter on it that describes in so great detail on how the borrow checker resolves all lifetimes and how the actual step-by-step process for the borrow check is. And it shows a couple of very clear examples where lifetimes come into play. And once you read that, you get it. So you don't need to find the process anymore because you get it how it works. Highly recommended. So Advanced Reading on TypeScript, great book. And especially the part on lifetimes was eye-opening.
Okay. Please compile not Rust, but a list of great resources later.
I'm going to send you a couple of links afterwards.
Mm-hmm. Can also post it on Twitter. I think this would be awesome for others as well. Also, they have been shared already, maybe, but in a condensed way around our meetup today would be cool. Cool. Okay, I think now
I'm going to hear my kids scream. I'm already 20 minutes over. I guess I need to leave, so I won't be there for the raffle.
Yes, but I think we can finish the raffle in 2 minutes or so. So if you like to,
cool.
Then we can just speed up and
let me just write the message. You start. That's good.
Okay. Thanks a lot. Let me just share my screen. One of the popular sentences in the last 2 years. Followed by, do you see my screen soon? Okay. That's now this live effect. Now I have some security issue. Okay, now you just need to, you just need to trust me. I have like a wheel of names running here. I put all the names of the participants in the chat into this wheel.
I've been there. You never opened StreamYard with this browser, I guess.
I think not with this major version. I think it's they did something with some settings I need to approve again, but I need to go into the system settings now, and this will take too long.
And you would need to restart the browser. Don't do
trust me. Yeah, exactly. Okay, but a nice learning for the next event. So I have a list. So this is how it goes. I have a list of all of the names who wrote something in the chat, like. Also the ones who came a bit later, and I will just run a wheel of names now, and you just need to trust me, and then it's rotating, and the winner is this was close, Matthias Andras.
So, congratulations,
Matthias. Cool, you won the book. So please reach out to Frontend RheinMain, to our community. We need to have your email address and of course your postal address and stuff like this. Just reach out on Twitter or write an email to info@frontend-rheinmain.de, for example, whatever you prefer. And then you get this lovely book. And we still have some more books. So in the upcoming weeks, maybe across other events, we will raffle some other copies. And And I think that's it for now. It
Cool.
was like 1 hour, 20 minutes of awesome talk, awesome exchange, nice question and answer part. We love to have you back at some point, Stefan.
Sure.
And
Fantastic.
looking forward to what you write about Rust in the future, what we see from you.
Let's see what's coming up. Oh, by the way, if you know German,
Yes.
I'm writing a monthly column for Heise, which is called Fairies Talk, where I'm writing about Rust. So if once a month, my friend Ryan and I are publishing something there, different insights. So we're writing about language features on one side. This is Weiner's part, and I write mostly about design patterns and applications. So check that out. If you want to have ideas and know how to speak German, go to Heise and look for Fairies Talk. I'm going to put that link up as well, I guess.
Okay. Thanks, Stefan, for your time.
Alrighty.
Okay.
Bye-bye.
Bye-bye.